do start your show.
Yeah, thanks. So let's see, let's share this one. I guess it looks fine.
Yes, looks perfect.
Okay, so I'm planning to tell you something today about zero knowledge use cases. I was kind of informed that you have some earlier thing about zero knowledge, about what it is and how it works some time ago. So let's not spend too much time about what on earth it is and how you can use it and so on. But let's have a look at some use cases and how I like to generalize them, also how I like to categorize those. So let's click this. A bit about myself. I'm Lauri Peltonen. I've been doing Ethereum development for some 5 years, and then a few months ago I started full-time freelancing for doing zero knowledge stuff and also Ethereum development. And meanwhile, I'm writing all sort of weird stuff about ZK and how it works. What are the mathematics, theory, use cases? How do you do development there? You can check out my some of my stuff if you want. So let's just dig in. I'm not going to have like very many slides. This is mostly to kind of raise questions and to maybe recap what is ZK and what we could discuss then. So a quick recap, what is ZK? We have this prover. It's a heavy computer sitting somewhere, usually, which takes a while to generate a proof, and the proof proves something like you maybe have some data or you have some algorithm or something similar. So it's something that you don't want to reveal to others usually, and you want to generate a small proof based on that. So once you have this proof, you maybe send it over to someone else, or maybe send it on chain in some blockchain which has this verifier program. Maybe it's a human who does the verifying with some program, or maybe it's somehow automated. But anyway, there's some entity which has this special kind of program which verifies the proof. And what the verifier verifies is that they have the same logic as in the prover program, and they verify that the proof that you are sent, it has the right stuff. So basically, it verifies that you have the data that the prover says that they have. Now, this is the very basic overview. If we go quickly through some use cases, I like to categorize it into three different cases. The first is the succinctness, which basically just means it's a small size. So this is often used in blockchains for like layer 2 rollups and this kind of stuff, but let's have a look a bit later in more detail. So the whole point of succinctness is that you have a small proof size compared to the original data. So you might have like 10 gigabytes of data, but from that you generate only a small proof that you can send somewhere. And the actual size of the proofs, it depends on the used zero knowledge technology. It can be static, so it's always the same size, or then maybe it's some ratio compared to the original data. It depends. The second use case, I call it verifiable computation. This is a bit more theoretical one. This basically means that you have some complex computations that you want to complete, but you don't want to do it yourself. So you basically send this you ask someone else to do the computation, but you also want to make sure that they did it correctly. So what they do, you send them do these kind of things. And what they do, they send you back the result, but they also send you a proof of the result. So the actual result might be very complicated. It might take you like, I don't know, days to figure out if it's correct and if it's what you wanted. But if they send the proof for the result also, it takes like 1 second to verify the proof, and then you know that they cannot cheat. So you can kind of like outsource your heavy computations to someone else. And you don't have to trust anyone here. And the third is privacy. which is, I think, the most interesting use case, which means that you don't want to reveal anything of the data or anything of the things that you are generating the proof on. So if it's some maybe your password or something, you don't want to reveal your password, but you want to generate the proof that you have a certain type of password. And let's have a look at this a bit more in detail also later. This succinctness for people who have been around blockchains, this is maybe the most typical one that you come across. I think all layer 2s, at least all ZK rollups, they use this kind of succinctness. So what a blockchain usually has, we have this bunch of transactions, like a chain of transactions, and you bundle a bunch of those, you generate a proof for that bundle. And what the proof basically proves is that the end result of these transactions looks like this. And then you can send this proof to someone else who wants to verify it. So usually the verifiers are layer 1s who want to verify, hey, the layer 2 is doing the right thing, and the layer 1 verifies, yes, it was correct. And if the layer 1 verifier says, oh, no, this was not correct, then all the users in the layer 2 know that something fishy is going on in the layer 2. So you can basically pack a bunch of transactions into one transaction. So you save a lot in the space and in the computation, because you only do the proving once, but the verification is very fast and cheap, and that's going to be done on the layer 1. So basically, it can be used also in whatever internet communication. If you have lots of data, you don't want to send it all, but you want to prove to someone that you have the data. You can just send a small proof that you have the data. And basically in whatever ecosystems, if there's like lots of something, maybe their bandwidth is limited, you cannot send all the data or something. You want to fit in a SMS or something, like there's no space for it. So you have something big, you want to prove with something small, so you just generate a proof for it. And this is a bit more theoretical, the verifiable computation. As I was saying, that basically you can send your computation to someone else. Here it's, for example, a cloud service provider. Let's say this is an Amazon. You send your calculation there. Maybe they calculate it for a month or whatever. It takes a long time. And then they have a prover there also. And you both agree on what the prover does. And they generate the proof for the results, and you get to verify the results and the proof. So you are the one doing the verification here. This is something which I don't think anyone does yet. There are some use cases for blockchains which are now being used, but it's not anything in big scale. So it's currently like on kind of trial basis, I would say. So let's see if this will take off. And the last use case about privacy. So the whole point is that you have some sensitive data, some sensitive information you don't want to send anywhere. So you can protect this with zero knowledge. You generate the proof, and this is also kind of tricky. Even if you generate the proof of the data, it doesn't necessarily hide or hold the information. So even if you have a zero knowledge proof, it doesn't mean that there's zero knowledge revealed about the data. Or not all the zero knowledge systems are equal. So only some of them support actual privacy. And the rest, they basically leak some information at least, or maybe they leak like all of the information. It depends. You have to be careful about what is real privacy and what is just wannabe privacy. And for blockchains, what you could use, like where you could, for example, use privacy, whatever, like hidden marketplaces, like you don't want everyone to see what kind of trades you are doing. You want to swap these tokens, but you don't want anyone to know that you are swapping these tokens and these kind of things. Maybe you want to hide all your transactions like altogether. Maybe the network provides this kind of services that you can just generate the proof that something is done, but nobody knows what actually has been done. And maybe some gaming stuff. This is something that's coming also to the blockchain world quite fast and quite heavily. Things like partial information, whatever that might be. It quite often in online games, you don't have all the information. So this is a very big thing that I think will be one of the first things where blockchains will be very useful with zero knowledge. It of course depends also a lot on the blockchain part. So does it enable all the transactions that are needed in gaming, and it makes a lot of requirements for the blockchain also. And yeah, I think that's for my slides. So basically, whatever questions you have, I think now is the time.
Perfect. Thank you, Lauri. Let's see if I can put you here a little bit bigger. No, swap. I know Web3, but I don't know ATK.
Maybe you can apply some zero knowledge there.
Yeah. So this is the biggest that I can, well, you guys can see him roughly. So
yeah, I will just stop.
yes,
yeah.
Perfect.
Now it's bigger.
Now it's bigger. So maybe I will, yeah. Okay, perfect. So questions, I have few, but I will let you guys shoot first. It's a big topic that I know this little, so yes.
I do see like ZK proof in voting, like sort of, there's been in voting quite a lot of questions, especially like holding like large worldwide events that so far blockchain haven't been able to solve the problem of like, how do you make sure that people don't see who do you vote for, because then they shoot those people. So how do you, like, can ZK proof be a solution to this one?
Did you hear the question?
Yes, yeah, I heard it, like ZK and voting. I think at least partially. It depends what the requirements are. Like, well, voting kind of seems straightforward, but then when you start thinking about it, there's like, what are the exact requirements, and can you like change your vote and this kind of things. There's if you're interested in private voting stuff, there's a grant ongoing. You cannot apply anymore, but if you know this kind of DAO called Knowns DAO, they had a grant a few months ago, and a company called Aztec and Aragon won the grant, and they're building private voting system, and they have published, I think, 3 milestones for it so far, and it's really, really complicated. They are using ZK for it, but I don't understand half of the stuff they're telling there. It's really complicated to get it actually to work. But in theory, it's doable. But it depends on the requirements.
Yeah. Cool. I would love to see that kind of voting happen in Finland, that, you don't have to go to a school to physically vote, but you can do it.
Yeah, this is also related, like proof of personhood. That is like a hot topic nowadays also. Like, if you have an address, how do you prove that it's a living person behind the address, and who can vote? These kind of things. That's a very complicated topic also.
Yeah, and related to that AI, how do we prove kind of that this is a human now tweeting, or is it Xing, or is it an AI? So
yeah, if it's just like any address can vote once, then it's easier. But then if you have to be human.
Yeah. Other questions? Yes.
I'm kind of curious, because everything always has a pretty personal story behind it. Somehow, it's like, first of all, how did you find this interesting where you first saw some useful application of it? But what are you, even more importantly, now passionate about? What do you want to see implemented, and or maybe working on something that is the use case for you that is like a.
So what I find interesting and what kind of use cases I see like next happening, if that was the question, roughly.
No, you're passionate about yourself. It's like not just in general the implication of something, or are you working on something specific that you think is important to happen right now?
Yeah, I'm applying personally applying for a grant to do a website verification with zero knowledge. Like you go to an adult website and they ask you, are you 18 years old? And then this could be done with ZK. in theory, there's a lot of work there, but these kind of things I think will be coming, and I think these kind of like places are good starting points to get some real actual KYC service providers to actually provide you with the data in a format that is acceptable for generated ZK proof. So I think we should start somewhere, like start small, and then at some point, like maybe do something bigger there.
Immediately, it sparks like an emotional reaction. So I think you're onto something there.
Yeah. Now thinking of my daughter, if she watches something on YouTube, she has that kids filter, but sometimes that fails. So something really ugly pops out. So how is it possible to use zero knowledge for content in a way that you kind of label it as, you know, adult content?
Yeah, I don't think you need any zero knowledge there, but like maybe AI to recognize what is what.
Yeah, YouTube hasn't, you know, been able to do it, so that's what I'm thinking. Would this solve it? But yeah. Okay, good. That was our question. Yes.
So you talked about like not all zero knowledge proofs are private, like, and I wanted to ask, like, is it how you write the circuits, or is it about the protocol you use, or what do you mean by that?
Yeah, it's a good question. I would say that the things that are really private, they are very explicit about it. So when you write these ZK programs, you have option: should I make this public or should I make this input private? So they're very explicit about it. But then the things where things are not private in reality, they don't talk about it. They don't prefer to advertise that we are not private. So this is stuff like ZK EVMs. I don't think any of them actually have privacy. So it's sometimes if you have something ZK ecosystem, it's difficult to know if they have privacy. But unless you go to the language itself, see if they have like private keyword or something like that.
That answered the question. I didn't understand the question. Other questions? Yes, please.
So maybe I'll try to ask a question. I'm not sure if I can sort of ask it clearly yet, but I'm thinking about a situation where tools and ownership of tools is a question. So maybe like a development environment that some expert might want to take them with between different employers or different use domains. So so I'm thinking about how those personalized development environments can travel, and thinking that they have to move through different scopes, data domains, different privacy domains, maybe even different jurisdictions. And I think I was wondering, might this zero knowledge technology be something that could be used to facilitate those kinds of boundary crossings? Does the question make any sense?
Well, I'm not sure what kind of tooling you mean, but if we assume that we have like perfectly working like proof of personhood, so everyone has like a proof that they are like this person, then you can generate this, like based on that proof, you can generate a lot of other stuff. Like maybe you can prove that you own this thing and put it somewhere, and then you can use it elsewhere to prove that yes, this is mine. But I guess I didn't really understand what kind of like tooling you mean. So I guess it depends.
You want to specify a bit?
Well, yeah, I'm thinking like a developer who has their own personalized development environment. That's probably going to be AI driven in the future, and probably owned by some entity, some corporation that they work for. And maybe they would want to use their expertise in some other place. Maybe they would want to volunteer somewhere. Maybe they would want to be able to build a website for a sports club. But to use their expertise, they would actually have to take the tools with them, or at least access to the tools. And I'm thinking how to facilitate that kind of boundary crossing in the future.
And what
corporations? Yeah, just what were you saying?
Yeah, I was thinking, would corporations even allow that? No, whether even the technology would be there.
If we can prove that their data stays safe, it might be doable.
Yeah, that's an interesting.
Yeah, for the data, it's kind of like much more like straightforward because you have the data and you can generate what kind of proofs based on it. But for the tooling, that I think that's a lot more complicated. Like I don't think zero knowledge is the first tool I would choose for that, at least.
And for me, it's more of a kind of a corporate issue. Would they allow you to use? I mean, they are paying for licenses and whatnot. I don't know. There's some. Yeah, I don't know. That's really interesting. Huh. Good. Huh. Other questions? Yes.
What is your mathematical background, and how do you see how deep in zero knowledge can you go with which kind of level of mathematics? How do you see it?
So IQ and all those.
Yeah. Oh, that's a horrible question. Yeah, if I guess you have at some point peaked about mathematics behind zero knowledge. It's horrible. It's absolutely horrible. So if there's a person who has like a high school mathematics background, it would take a million years to go through it. I took like 5 courses in the University of Mathematics, I think, and it's very weird to see that now I would need all of the stuff I studied, because back then it's like, I'm never gonna need this shit, I don't care. But now there's actually something where this would be useful. Like all the mathematics I have ever done, it would be like almost all of it would be useful here. So it takes a lot of like different kind of mathematics and different kind of things for you to get down in the rabbit hole. But once you fall into it, and if you really want to, you can like go like really, really deep. There are some of these ZK communities where I'm just, there's an active Telegram channel. It has like maybe 100 messages per day. I understand maybe like 5 of the messages what they're talking. I'm like, I have no idea what you guys are saying, but this is fascinating.
So not a group for me.
But okay. It's really fun to see more smarter people than yourself.
Then I will just copy paste and chat GPT, please, explain it to your dumb.
In human language.
Yes. Okay, other questions?
Can I ask like a stupid question, a pure question? So like, I know nothing about like zero knowledge technology, except for maybe a few things at classes. So what does it have to do with mathematics, like directly? Like, is it some understanding like of principles, or what is the thing with mathematics?
Yeah, the biggest thing about mathematics is when you're generating the proof. What the proof basically does is you have a bunch of code, which is called the prover program. You have whatever code is there, you basically write it. And once you want to generate a proof for this your program, it makes it basically into polynomials, and then does all sort of like weird magic to the polynomials to generate certain types of commitments to the polynomials and your input data. And basically and the result is just one proof, which is a string of like nonsense characters. And that's all there is output. And then the verifier is like, that's the other piece of the puzzle. It has the same logic. It just takes the string and outputs yes or no, and that's all. So how to make this kind of like a tooling and how to make this gearbox working, that's where the like very weird mathematics comes into play.
So but then related to that, do you believe that in the future there will be kind of ready plugins that you can just use? Yeah, you don't need that, math background.
Yeah, this is actually something that I forgot to include in the presentation, like development. Nowadays, there's like quite good development environments and languages which you can use to develop almost like normal code, and it just does all the magic behind, and you get a proof for it, and it even generates a verifier for you. So you basically almost write normal code. Of course, you have to kind of know a bit like what are you writing and why and what's going to happen to it. But you don't have to understand anything about the mathematics. So that part is like going quite well. but then it's like their background research, like that's going like light speed. There's lots of like stuff coming out all the time.
Yeah. Okay. We have time for 1 or 2 more questions. Yes, Lassi.
One thing that's been quite confusing to me is like when you're developing these kind of things, does the public witness hold any data? Like are there like public variables? If someone gets a witness, can they read it and read what's in it? Or is it just a schema for the prover to like know what it needs to do?
It depends on the used proving system. Like some of them like provide this real privacy, and then you can basically decide like you have two inputs. This one is public and this one is private. And if it's private, nobody will ever see it. But if it's public, it's in theory it's very visible.
You are too smart for me. I have one more question. I'm not sure if it's a good one, but criminals are usually quite, quick to adopt new technology. Like, crypto was used by criminals kind of quite rapidly. Now AI, everything. So, do you think that, or have you heard of any cases that ZK has been used for bad things? Because that's kind of a
that's a good question. I'm sure some of you are somewhat familiar with the case of Tornado Cash. It was basically a token mixer in Ethereum, and well, it is still there, where you input some tokens and or Ethereum basically. You input some assets and out comes like assets in different formats basically. So nobody sees what's happening inside. And this was used extensively by North Korean Lazarus hacker group. And there's like lots of discussions like who is responsible and should somebody be in jail for this? Like if you make decentralized application, like who do you put to jail? They found some people to put in the jail, but that's like a bit different, a longer story then.
Yeah, but so they use zero knowledge there, or?
Yes, it's all based on zero knowledge.
Okay. So my hunch was right. So they smart them criminals. Don't do that, you guys. Okay, perfect. Hey, thank you, Lauri, so much. Maybe kind of I would encourage everybody to follow Lauri on LinkedIn. He's posting a lot of ZK stuff there, which kind of it's super amazing. You have your own blog posts and everything, and now hopefully having that ZK course available at some point as well, right?
Yes. Yeah, just poke me wherever if you have more questions, and let's see what we can figure out.
Yes.
What was your surname again?